today. This is our first lecture for our subject Thermodynamics 2. Okay, so for our first topic, we will discuss about the topic Exergy. Okay, Exergy. So maybe it is quite unfamiliar to most of you, this word, but Exergy is nothing but just the work potential. Work potential or the availability. There are some textbook call this one as the availability. Okay? So what is Exergy? So Exergy is just the term that you call for the maximum work that you can extract from a given system. Okay, say for example you have a waterfalls. Okay, so if this is the waterfalls, this has an elevation h. Okay, so when you are if you want to get the maximum work potential that you can get from these waterfalls or resources, you need to conduct an exergy analysis. Okay, so that is why we need to study this one. Okay, we need to do an exergy analysis. Okay. The maximum work that a system can be extracted is ano sa man occur when first is there are no irreversibilities. Okay, so this is the first requirement, no, in order that you can extract the maximum work. And then para na ay work na makuha, there must be a difference. Okay, there must be a difference between your system and the environment. Okay, and the environment dapat na ay difference ano nilang duha. Difference in terms of its state or their properties. Okay, so kanilang duha ka variable ang atong kinahanglan in order to get this exergy. Okay, so first let us define what is an environment, or specifically the exergy reference environment. Okay, Exergy reference environment, unsa man ni siya? Well, okay, if this is your system, say for example this is the exhaust pipe. Okay, exhaust pipe of your motorcycle. Okay, say for example this is your system. Okay, and then from thermodynamics 1 we draw the boundary. Okay, the boundary. Outside the boundary, that's what you call the environment, right? Environment. So ang surroundings nga doon sa imong environment, say for example this one, diyan ni dapit, maka-experience man na sila of change in its intensive properties. So what are those intensive properties? Properties like temperature, pressure, right? Okay, so ang temperature dire as compared sa diri nga dapita, mas greater gini siya. Naman, mas doon man ni diri. Diri man gibuga ang mo ang combustion gases. No? So, diri nga part, although part nasa sa environment, but dili na siya mao ang Exergy reference environment. Ang Exergy reference environment is kanina diri dapit. No? Kani diri dapit. Layo, medyo layo sa imo ang surroundings, layo diri. Nga naman, because ang isa ka requirement sa imo ang Exergy reference environment is ang iya ang intensive properties does not vary. Intensive properties does not vary. Okay, like temperature and pressure. By the way, we put this kani T sub O, no, in order to denote ang properties sa imong Exergy reference environment. Okay, another property sa imong Exergy reference environment, extensive properties may change, no? Pwede mo change ang extensive properties. By the way, ano saan yung extensive properties? Di ba? Ang extensive properties are those properties that you can add up, or pwede mo siya mabahin-bahin, like mass. Pwede mo siya divide into smaller pieces, volume, right? So pwede mo change ang iyang volume, internal energy, among others, right? Okay, pwede na sa mo change. And then, okay, by the way, ang value aning T sub O, na ko isulat, hindi na lang. T sub O, if given sa problem, this is ang reference nila sa book 25 degrees Celsius, and ang P sub O is 1 atm. Okay, but kung given, katong given ang gamiton. Okay, so if ang extensive properties, okay, so napa ni sa line ha, entropy, volume. Okay, so kung mo change ang extensive property, how do we determine the change of the extensive property? So we will use this equation, the TDS equation, du plus PdB, right? Or kung gusto niyo kuha ng change sa internal energy, du is just TDS minus PdB. Okay? Or in terms of finite values, T sub O delta SE minus P sub O delta VE. Okay? Take note aning equation, we will use that later on. So mao ni siya, no? These are the relationship between the change in internal, change in entropy, and change in the volume. Okay? Okay. What are the properties? So may property aning by the way, kaning Exergy Exergy ani, ang unit ani niya is the same sa energy. Joules, kilojoules, right? The same na siya nga naman kay this is just work, maximum work. Okay? So ang exergy, this is a property of your system. Okay? Property of your system. Meaning, ani, diba, ang energy, when you talk about energy can never be created nor destroyed, but it can be transformed. Right? Ang exergy po nimo, kalahian nila, ang exergy nimo is kani siya, exergy can be destroyed. Exergy can be destroyed. Sa pa lang property yan eh. Non-negative value. Meaning, hindi siya pwede mag-negative, but pwede siya na zero. No? Kung ma-zero siya, muna siya nagtawag na exergy is destroyed, or the potential for work is destroyed. Kano saan na siya may tabo? Say for example, na kay can diri, no? Dinaan siya high pressure air diri. High pressure air. Abriya kung i-vent out nini mo sa surroundings, no? 'Di ba? Ang duharam ni ka factors, system and the environment. Kung i-vent out nimo ni siya sa environment, unsa may exergy ani is zero. Wala kay work na harness, no? But kung butangan mo ni siya turbine diri, small turbine, di naka-harness ka work. So, mo na siyang gitawag nga exergy can be destroyed, or the work potential can be destroyed. Okay. Sa panglaing properties sa exergy. Okay, by the way, nalimutan na ako, no? If this dot is nag-represent aning exergy environment, kung ano yung environment, so naano siya sa TO, right? Kung ang imong system na adire, no? System. Kung nasa dire, no? Kung naay difference sa imo ang system properties, kung naay difference sa properties sa imo ang system and the environment, you have an exergy, no? Nasa exergy, no? And then kung magkaduol ni dire, magkagamay ang exergy or the work potential, no? So dire, compare dire, mas dako ni exergy dire. Okay? So mo na siya. Okay, another term, nanlit. Okay, another term na tong i-define is dead state. Dead state. Ano sa man may tabo ng dead state? Kung balikon to, kung ano yung system dere, na dere yung environment, once gani nga maabot na siya dere, same ng ilang properties, that was what you call the dead state. Dead state, no? Okay? So, diri sa environment, okay, diri sa environment nimo, again, no, kung sa may na diri, naagya po ni siya internal energy. nasa internal energy. But wala na siya kinetic or potential. Like example nato. Katong waterfalls, no? Kung dire ang imong environment, paghulog ana niya dire, wala na siya. Siyempre, kung stagnant dire, di wala na siya kinetic, wala na po siya potential. Wala na po siya potential energy. But nasa internal energy. Okay? Okay. So, ang energy nga na-contain sa imong system, ang energy sa imong system is nasa kinetic, nasa potential, plus nasa internal energy. Okay? Ang imong system, ay imong environment, ang energy dire is just equal to internal energy. Okay, based on that, we will now derive the mathematical representation o kung saan na to pag kuha ang value ani. Okay? How do we get the value of the work potential? Okay. So in order to get that one, let's have this. Kung mawani mo ang system, by the way, this is a closed system. Naani siya yung boundary. Sa boundary. And then, kay environment. For example, muna yung environment. Okay, so ang Exergy is just the work potential. Work potential sa unsa? Work potential sa combined system. No? Unsa ang work potential sa system and the environment? This is your environment. No? So, unsa ang maximum work? So, that is just mo ni siya. In the book, ang symbol ani is E. Ang kaning symbol nga E, di same ra ni siya ani. So, kung makuha na to ang value sa Exergy. Okay, so unsa man ni siya pag-analyze karon? Okay, so sa imo ang environment, wala na nag-change ang temperature and pressure. Okay? But possibly mo change ang extensive property like volume, no? Volume. Mo change ni siya. Mo change. So unsa kadako ang change ani? No, so according to the book, no? Dapat ang change niya, kung mo change ang imo ang kaning volume, mapasabot ani kaning volume combine ilang duha. Volume sa system, volume sa environment. Dapat ang total volume nilang duha is equal. So kung mo expanding system nimo kay nasa process na rin mo expand na siya. So dapat ang environment nimo mugamay siya. Ano man? Unsa kadako yang paggamay. The same value sa imong sa pag-expand ani. Ngano man para ang total volume is the same. Total volume is the same. Okay, so unsa na siya? Okay, so dire no. So kung wala na nag-change ang temperature dire, so sabot ana niya, wala na naka mo gawas dire nga heat transfer. Na-contain na siya, meaning na-contain na siya within dire, wala nakagawas dire. So ang pwede ra mo gawas kay kani man natong ipangita kanira work. Right? Okay. So, unsaon nato na sa pag-analyze? We apply the first law. Okay? First law of thermodynamics. Kung ano ning i-reason na. Okay, ako ning pag-amyun lang. Like ang first law dere, change in energy is just equal to Q minus work combined. Okay? Combined work. Since wala heat transfer, so zero ni. Zero. And then, pangitaw na to ang kani. Unsa ni siya? So, ang value ani niya, change in energy, is just change sa energy ani sa imong system and then the change in energy of the environment. So, change in energy of the system plus change of energy sa environment. Okay? So, what is the change of the system? Energy of the system. Ano change niya? Diba? Based sa ato ang atong analogy, kung mo yung system, this is your system, this is your environment, naan siya ay kinetic, potential, internal. Right? And then, mabot niya siya diri. So, unsay may tabuan eh? Sa may tabo niya, wala na sa kinetic diri. Internal na lang. Same na sa... Siyempre, dapat para makuha na to ang work potential, dapat maabot sa diri. No, na-exhaust na niya ng kinetic potential. Kuha na lang, kanina lang. Ang yang internal energy mo pareha na sa imong environment. So, this is just U sub O minus so man minus kani minus kinetic PE plus U na minus ana, right? Oh, by the way, ito na sa ning i-denote as E. Denote na sa nato ni as E. Later on na nato na bungkagon, but eventually ang value ni is just kaning tulo. Okay. Kani. Plus again ang change sa energy sa environment. Sa ang change sa energy niya, this is just the change in the internal energy. And then, base kaganiha, ang value ani is katong TDS ng equation. This is just TO delta SE minus PDB. Right? TO delta SE minus PO na. Right? Okay. And then, kani nga value, itong i-substitute dire. Therefore, and then negative man so may man the work potential is just balihon na ito may man E minus U sub O and then minus plus PO delta VE minus TO delta SE. Okay. So, mo na siya. Ano pa ang term na itong kinahanglan ko ani? We need to get the value sa entropy. Ano ang value sa entropy ani? Ang value sa entropy is will get the entropy balance for a closed system. Okay? Kung ma-recall ninyo, kaning value ani delta S is just atong Q over T plus sigma. Right? Oh. But since wala heat transfer, so may mo ni zero. Kanina lang, may mabili na. So mahimo ni siyang by the way, okay, so mao ni siya na mahimo na ni siya delta dali na lang delta SE kana, right? So mao na siya, but no. SC combine SC sa ning reason but kaning delta or the change in entropy of the combined system ani, so this is just equal to change in entropy sa system plus change of entropy sa environment, right? Ang change of entropy sa system nimo is just kung unsa ang entropy sa, di ba, again 0.1 then mo ning environment, pag abot niya diri ang final entropy is just the same na sa environment, so mo ning S sub O minus the initial ano siya plus delta SE. Okay, so therefore again ang value ani is kani, so subject nata yang ikuha na to ni para makuha natin yung value ani. Okay, so kani di ay siya is just delta SE is just sigma C minus SO minus S, right? Therefore the work potential is E minus U sub O plus PO delta VE minus TO plus DI plus TO minus na lang, ito na lang balihan, minus balihan natin eh S minus SO plus minus DI kani minus. Okay, kani siya, so mo na ni ang imuang energy balance at ani nga system, but ang again ang atong purpose is to get the maximum work that can be extracted from the system, from the combined system. So para makuha na to ang maximum work, dapat again no irreversibility, so pat zero ni. Therefore ang nabilin mo na ni siya, E is just plus ito ning ilahion, no? Lahion na ito ni siya nga symbol para dili ka ma-confuse. Ito na lang ning ana. Exergy is just energy minus U sub O plus PO delta VE minus TOS minus S sub O. Okay? So, mao na ni karon ang ato ang equation sa atong Exergy or the work potential, maximum work potential. Okay, so unsa ang mga variables nga kinahanglan nato kuhaan, we need to get the energy of the system. Also, we need dapat kaning mga naay subscript nga O environment. So you need to get the entropy, temperature, pressure, internal energy. Kani again kaning E kaning A is just kinetic plus PA plus U. So this is just 1/2 mv squared plus mgh plus U. Right? Muna siya. Z man dahil ng quantary. Gamit sa book, Z. Okay. Now, kung imo ni siyang i-divide of M, may mo na ni siyang specific Exergy. Specific Exergy. So, ang equation na ni will be E nga gamay and then U minus U sub O ang kaning E nga dako ato ni bungkagon og U kani divide nato nag N U plus 1/2 V squared minus plus GZ minus U sub O plus kani PO delta VE minus TO S minus S sub O. Okay, or ang ato na yung paggawas ay mga name U minus U sub O plus PO delta VE minus TOS plus 1/2 V squared plus GZ. Okay? By the way, butangan na to ni og ana para makabalot ang velocity ni velocity. So this is it. Later on, we'll have an example. Okay, so let's have an example, and we have a cylinder in an internal combustion engine that contains 2,450 cubic centimeter of gaseous combustion products at a pressure of 7 bar and temperature 867 degrees Celsius. Just before the exhaust valve opens. Okay, so this is your exhaust valve. Okay? So kung paubos na siya, muna i-open. Then magawas ang combustion products. Okay? So determine the specific exergy of the gas. So we need to find this one, specific exergy in kilojoules per kilogram. Ignore the effects of motion and gravity. and model the combustion products as air as an ideal gas. Okay, why do we need to model this one as air? Yan naman, because ang mga products ani, you have CO, kung incomplete combustion, you have CO2, you have water, no? So complicated, no? But eventually sa chapter 13, isa-isaho na sa kuha, no? Isa-isaho na sa kuha. But for this chapter, we just focused on how to do Exergy analysis. Okay, given ang pressure and temperature sa environment. So, what you need to do is, since there is no kinetic and potential, so this becomes plus TO plus P. PO V minus VO minus TOS. So we need to get these parameters. Okay. First, kanina term. By the way, I will now erase this one. Okay. Change in internal energy, since given model na to siya as ideal gas, so it will just be a function of temperature. So from table A-22, you will get the based on the temperature, you will get the internal energy, which is 880.35, and then based environment temperature, you will get 214.067. Okay, so this is just 666.28 kilojoule per kilogram. And then this one, evaluate this one, S minus SO. So sa equation na S degree of T. So T, ang katong temperature sa kani 867 in Kelvin. 867 plus 273, 1140 minus S degree of pila tong environment temperature, 300 minus R bar M ln T over PO. No? And just plug in the values na sa table. 3.1183 minus 1.7 0203 minus 8.314 molecular weight 28.97. By the way, i-check ninyo ang unit ani ha, para dili mo masayo. And then 7 divide therefore ang value ni is, again, always check the units, dapat consistent. Okay. And then, kung i-multiply nimo ni siya by TO, you will get 258.62 kilojoule per kilogram. Kilogram niya, kilogram. Tapos click ka ni PO V minus VO. Ganit. Okay, so let us evaluate kani nga term. Okay, so let us, from the ideal gas, let us get the value of this specific volume. So mao ni siya ang, by the way, this one. This is the ideal gas equation. Okay, so we will now substitute this equation there. So you have this one, and then collect the R bar over M kaniyang mabilin, and then plug in the values. We will get a value of negative 38.75 kilojoule per kilogram. And then, since na kaning tulo ka values, plug in there, you will get a value of 368.91 kilojoule per kilogram. Okay, so unsay importance ani nga value? If you will multiply this one, no, if you will get the mass flow rate sa imong combustion gases as it exits the exhaust pipe, you will get the power output, no, makuha nimo sa exhaust gas. Okay, so based on that one, say for example, kung pag multiply nato ani og mass flow rate, ang nakuha lang nato is 5 watts. Maximum power output is 5 watts. Is it worth it ba ha magbutang pa ta og turbine diha? So mo na sa importance aning value, aning Exergy. Aning Exergy value. Exergy value gives you the maximum work potential, no? So based on this one, ma-evaluate nimo kung naay mag-claim nga maka-produce na og 10 watts niya based on Exergy analysis, 5 watts lang, meaning dili na tinuod. Or kung naa kay Exergy nga value, naa kay standard nimo, no? Kung mao ni ang Exergy niya, and then ang output sa imong system naa pa dire, meaning naa pay dako nga at chance to improve the system, no? Pwede pa naman siya, pwede pa din ni ma-increase ang efficiency dire kung akong pa-improve din ang system. So muna siya uses aning value. That is why you conduct an Exergy analysis, no? It gives you the maximum value. Dili na nimo pwede malapas, dili na nimo maabot pod, but kuha nimo na kay value nga gusto nimo i-attain. Dapat mas duol diha, no? Kung mas duol na diha ang work na nakuha sa imo ang system, meaning efficient na siya, ano? Kung duol na, kung mas duol pa imong nagka-improve ang imong system. Okay, so that's it.